Okay, let's wrap up 5.1 by completing example 5. Now, this is about applying the addition of radical expressions. Consider the design shown for a skateboard ramp. What is the exact distance across the base? Well, in order to do this, you have to remember something from Chapter 2, and that is how to derive our exact trig values for 30 and 60 degree triangles. If we start with an equilateral triangle that has sides of 2 by 2 by 2 and split that right down the middle, we'll create a right angle triangle on one side that has a 60 degree, a 30 degree, and a 90 degree angle. So let's just redraw that. The bottom is 60 degrees and the top, of course, is the 30 degrees. Now if the bottom is cut in half, it's now going to be 1. The long side, the hypotenuse, is going to be 2 still. And if you used a squared plus b squared equals c squared, you can figure out that the third side will be root 3. Now, we have 60 degrees from one angle, 30 from the other. We can use this to derive our exact trig values. Let's start with cosine. Cosine is opposite over hypotenuse. So from 30 degrees, opposite is going to be 1, and hypotenuse, we're going to start with 60 degrees. Nice. Sine of 60 degrees is opposite, which is root 3, over hypotenuse, which is 2, so the sine of 60 degrees is exactly root 3 over 2. Now we'll do 30 degrees. So the sine of 30 degrees is, as I said, opposite 1 over hypotenuse 2. The sine of 30 degrees is 1/2. The cosine of 30 degrees, well, from 30 degrees cosine, that's adjacent, root 3 over hypotenuse 2. And for the cosine of 60 degrees, you're going to get adjacent, which is 1 over hypotenuse, which is 2. Well, we don't know which trig ratios we're going to need on this triangle, so we'll leave tangent. If we need it, we'll come back and derive it. And let's look at our triangle. They want to know the distance across the base. Well, if I call the first part, I see two triangles there. We're going to solve them separately. In the first triangle, I'm going to call the distance across that base x. So I'm going to create my triangle. I'm going to stand it up, just spin it over to the side. And when I look at it, I see that from 30 degree angle, the opposite is 40 and the adjacent is x. Opposite over adjacent means I have to use tangent. So we need a tangent of 30 degrees. So if we go back to our triangle, well, we'll set up our equation first. And we'll say the tangent of 30 degrees is opposite 40 over adjacent x. Over here, go back to the other side, and the tangent of 30 degrees has got to be opposite, which is 1, over the adjacent, which is root 3. Pardon me. Now, go back to our equation. The tangent of 30 degrees we can replace with 1 over root 3. 1 over root 3 is equal to 40 over x. Simple enough. Cross multiply. 1 times x is x. 40 times root 3 is 40 root 3. That's the distance across that part. Now let's do the other part. We're going to call the smaller triangle, the side we're trying to find, y. And we're going to say now that the tangent of 30 degrees has to equal opposite over adjacent, which will be 30 over y. Again, replace the tangent of 30 degrees with 1 over root 3 equals 30 over y. Cross multiply, and y will equal 30 root 3. Now we've got our total distance across the bottom in exact values. The bottom is going to be 40 root 3 plus 30 root 3, which is 70 root 3. Now, that's the end of what we're going to do. You can go and do all of the your turns.